Now I am going to take the second problem of force exerted by a flowing fluid. So in this problem, the pipe is bent at an angle of 135 degree. See, this is the bent pipe makes an angle of 135 degree here. So how much is this angle? Obviously it is 45 degree, and in the problem it is given that the pipe is having the same cross section. Same cross section means here the diameter d1 is equal to d2, and that is given 300 milliliter, and after converting it becomes 0.3. Similarly here the pressure is also given. Here P1 is equal to P2, that is 39.24 Newton per centimeter square, and after converting into Newton per meter square it becomes 39.24 into 10 raised to 4, and the discharge through this pipe is given to you, that is Q is equal to 250 liters per second. After converting it becomes 0.25 meter cube per second. So we know the diameter area becomes same for A1 is equal to A2. So this will come pi by 4 d square. So this is 0.07068 meters square. After calculating the diameter, the next step is to calculate the velocity. So V1 is equal to V2. By V1 is equal to V2 because the area of cross section is same. So here we got the values of V1 and V2 is equal to 3.537 meter per second. Now the next step is to find out the force exerted along the x direction. So according to the impulse momentum equation, so here what is impulse momentum equation? Net force acting along the x direction is equal to the rate of change of momentum. So now I am going to consider the net forces acting along the x direction. This is the first force, that is P1A1. So P1A1. Then second force, flow is in this direction, so reaction will become in the opposite direction. So this Fx become minus Fx. Then the force, pressure force at section 2. See here, this is the pressure force which goes to along the positive x direction. So this again P2A2 cos theta. So this is the net force along the x direction, and that should be equal to rate of change of momentum. So rate of change of momentum is equal to rho Q. Rho is nothing but density, Q is discharge, is equal to final velocity minus initial velocity. What is the final velocity here? See, here is the final velocity V2 cos theta minus V1. Okay, so after rearranging the term, we'll get the equation rho Q V1 minus V2 cos theta plus P1A1 plus P2A2 cos theta. Okay, now I am going to put the values of density, that is 1000, then 0.25 V1. So here value of V1 is 3.537 minus V2. See here V2 cos theta. Value of V2 cos theta, V2 is 3.357 cos 45. Now put the values of rho, that is 1000, q is 0.25, velocity is 3.537 minus, see this v2 is v2 cos theta, it is in opposite x direction, so we have to put the opposite x direction, minus v2, that is 3.537 cos 45, plus p1 is 39.24 into 10 raised to 4 into A1, area is 0.07068, plus P2, P2 is 39.24 into 10 raised to 4 into A2, again 0.07068 cos 45. After calculating, we'll get the value of 48855.4 Newton. This is the force acting along the x direction, that is Fx. Similarly, we are going to find out the force acting along the y direction. So, after calculating the value of Fx, then Fy is equal to rho q minus v2 sin theta minus p2 a2 sin theta. So now put the values, 1000 into q is equal to 0.25 minus v2 sin theta minus v is 3.537 sin 45 minus p2 39.24 into 10 raised to 4 into area 0.07068 into sin 45. After that, we got the value of Fy is equal to minus 20236.3 Newton. Why this is negative value? Because whatever we have considered the direction, it is in opposite direction. After getting the Fx and Fy, then you have to calculate the resultant. For calculating the resultant, r is equal to under root of fx square plus fy square. So put the value of fx, that is 48855.4 square plus 20236.3 square. So the resultants becomes, so here we got the resultant, r is equal to 52880.6 Newton. Then find out the angle, that is the resultant, how much angle makes with the horizontal. That angle can be find out by using this equation, and here we got the angle 22 degree 30 minute.